Now, although we have seen how to find the derivative of a function using the first principles, that is the definition of derivative, every time it would be not possible to use that tedious method. So therefore we remember the derivatives of some of the most important standard functions and use them directly in all the examples. So here is the list of the derivatives of standard functions. Now firstly, if we consider the derivative of some constant k, which is a real number, then its derivative turns out to be 0. Okay, so that's a very important result. Derivative of a constant is always 0. Now moving ahead, if we have the derivative of function x raised to n, then it turns out to be n into x raised to n minus 1. Okay, so the degree of x reduces by 1 when we differentiate. Next we have the derivative of a raised to x. Now here a is a constant, which is a real number, which is shown on the right hand side, and a is greater than 0, that is it has to be a positive real constant, but it should not be equal to 1 because that's a requirement for the exponential function, right? The derivative of a raised to x is equal to a raised to x into log a. So as a special case, if we put a as equal to e, we get the next result, that is derivative of e raised to x is same as e raised to x, because we know that log of e will be equal to 1. Then next is log of x, whose derivative is 1 upon x. Moving ahead, here we have the 6 basic trigonometric functions, and we can remember their derivatives in a kind of pattern. The derivative of sine is cos and the derivative of cos is minus sine. So we see that the pairs are kind of alternating as positive and negative. Then derivative of tan x is sec square x, whereas derivative of cot x is minus cosec square x. So you'll see the pattern here in both the pairs. And lastly, the derivative of sec x is sec x tan x, and derivative of cosec x is minus cosec x cot x. So again we see some pattern in all of this, and that's how we remember the derivatives of these functions and use them directly. Now moving on, we see what is called as the algebra of derivatives, that is how to find the derivative of sum or difference or product or division of two functions. So let y, u and v be functions of x, and let k be any real constant. Now the first result is that if y is equal to k into u, then dy by dx, that is derivative of y with respect to x, is equal to k into du by dx. So basically when k is a multiplier to the function, that comes out of the derivative of that particular function. Okay, so k remains as it is when it is in the multiplier position. Now secondly, if y is equal to u plus or minus v, then dy by dx is also equal to du by dx plus or minus dv by dx. Next is y is equal to u into v. So here it is the product of two functions. Now remember that the derivative is not just the product of derivatives. Here we have to use a specific pattern, that is dy by dx is equal to u into dv by dx plus v into du by dx. So the way to remember is that it's nothing but the derivative of y is the first function into derivative of second plus second function into derivative of first function. That is called as the product rule. Okay. And lastly, if we have the division of two functions, that is if y is equal to u divided by v, then the derivative of y with respect to x, it has a very peculiar formula which we have to properly remember. In the numerator we have v into du by dx minus u into dv by dx whole divided by v square, and of course v should not be equal to 0 because v square is in the denominator, so which is the division rule. Alright, so these rules we have to use frequently in the process of finding out derivatives. Now let us solve a few examples based on the derivatives of standard functions as well as the algebra of derivatives.